Today, in this lecture, we'll discuss about the definition of electric field, definition of electric field, and then electric field due to point charge, due to point charge and multiple charges, multiple charges. Thereafter, we are having the electric field due to the discrete distribution and continuous distribution. Okay, na?
Okay, sir.
Fine. Okay. Fine. Fine. First, see here. Let us consider an point charge. Okay. And this, I am considering a point charge as positive. We can also consider the negative also. We can also consider negative also. Okay. This point charge will distribute its effect in all directions. Okay. Suppose, let us consider this point charge is distributing its effect in all the directions like this. Okay. Fine. Now,
Fine.
we are going to define about electric field. Or we can also say intensity of electric field. Intensity of electric field. It is defined as, it is the area region. It is the area or region bounded by the given charge. Bounded by the given charge, which will distribute its effect. Which will distribute its effect. Okay, can be called as electric field, or it is defined as ratio of force experienced per unit charge. Okay, per unit test charge. Suppose, let us consider here I am having an given charge F plus Q. Now, from infinity, we are taking an test charge. Let us consider we are having a test charge here, Q naught. So that this test charge does not experience any effect of the given charge. Slowly, I am moving forward. Here. Still no. Whenever I kept here, okay, then that means this test charge is at a distance R. Then test charge experiences a force, or test charge experiences the effect of the given charge. Can I say?
Yes. Okay.
At a closest distance, test charge experiences effect of the given charge.
Yes.
Due to this, there will be an force will act between these two charges. According to Coulomb's law, I can say F equal to 1 by 4 pi epsilon naught times 2 into Q naught by R square. Okay, na?
Okay.
So F by Q naught, by definition, electric field means F by Q naught. That is nothing but 1 by 4 pi epsilon naught Q by R square. Can I say?
Yes, sir.
So, electric field due to a point charge will be E equal to 1 by 4 pi epsilon naught times Q by R square. What is the value of 1 by 4 pi epsilon naught? That is 9 into 10 power 9. Remember this value. Most important. Many times will get.
Okay. One.
Okay, now. Electric field due to a point charge, it is E equal to 1 by 4 pi epsilon naught Q by R square. That means electric field due to a given charge is directly proportional to magnitude of the charge. Right? And electric field is inversely proportional to square of the distance between them. Okay. And electric field is proportional to permittivity in medium. That means if the same system, if I kept in medium, then electric field changes. Right? In air or vacuum means it is 1 by 4 pi epsilon naught Q by R square. If the same system, if I kept in medium, that is electric field in medium, we can write as 1 by 4 pi epsilon times Q by R square. Can I write?
Yes, sir.
Okay. Since by definition of dielectric constant or relative permittivity, it is K equal to epsilon by epsilon naught or epsilon medium by epsilon A. Okay, fine. So epsilon equal to K times epsilon naught. I'll substitute here. Electric field in medium, it is 1 by 4 pi times K epsilon naught into Q by R square. Bring K outwards. 1 by 4 pi epsilon naught Q by R square. It is nothing but electric field in A. This one. So electric field in medium equal to electric field in air by K. Okay, na? Is it fine?
Yes, sir.
That means as dielectric constant increases, as K increases, okay, we can say that electric field in medium will be less than electric field in A. Right?
Latent.
Fine. So by definition, electric field E equal to F by Q naught. Right? Fine. So
Fine.
Q naught, it is the test charge. Test charge is having a magnitude less than 1.6 into 10 power minus 19 coulomb. So in order to write like this, as Q naught value is small, can say limit Q naught tends to 0. It is not 0. It is approaching to 0. That's why we'll say Q naught tends to 0. I'll write here. Q naught tends to 0. F by Q naught. This notation you will have in your NCERT textbook. You can see same representation will have. Okay. That is what on the electric field and electric field due to point charge. Okay. Again, I am writing this formula. Remember, electric field due to point charge. Since here point charge I have taken positive, so electric field is positive. Equal to 1 by 4 pi epsilon naught Q by R square. If it is negative charge, instead of Q, I'll keep as minus Q. Okay, now.
Okay.
This is in scalar form,
Scalar, sir.
right?
Mm.
Okay, fine. Now, if you see the diagram, suppose here I'm having positive charge. This positive charge is distributing its effect outwards,
Oh,
right? Fine.
fine.
That means it is along the direction of the separation distance or position vector. Direction of electric field is along the direction of position vector. Can I say?
Yes.
So I can say that E bar equal to 1 by 4 pi epsilon Q by R square times R cap. In order to explain the direction, we'll use unit vector. Okay. So since by definition A cap unit vector means A bar by modulus of A bar. So like that, I am writing it as 1 by 4 pi epsilon Q by R square times R bar by modulus of R bar. Okay. Modulus of R bar, can I write as R? Okay. So it is 1 by 4 pi epsilon Q by R cube times R bar. Is it fine? That is in vector form. This is in scalar form. Okay.
Okay.
Vector form and scalar. Okay. Since electric field E equal to F by Q naught. So SI unit of electric field is Newton per Coulomb. Okay. SI unit of electric field equal to SI unit of force by SI unit of charge. Fine.
Fine, sir.
Next, electric field due to multiple charges. Due to multiple charges. Okay, fine. Suppose let us consider reference system as Cartesian coordinate system. X-axis and then y-axis. This is origin. Okay. With respect to origin, a charge Q1 is placed at a distance R1 and another charge Q2 is placed at Q3, R3. Okay. Let us consider, I am considering three charges which are placed at R1, R2 and R3 distance with respect to origin. Now, I want to find electric field at origin due to multiple charges. Due to multiple charges. Okay.
Okay,
That
sir.
is, I need to find E naught. So, due to the first charge, there will be field will act, and due to the second charge, and due to the third charge, right? So, electric field at origin, I can write as electric field at origin due to Q1, due to Q2, and due to Q3. Okay, fine. So, all these are point charges only. So, I can say due to Q1 means 1 by 4 pi epsilon naught Q1 by R1 square. Due to Q2 means 1 by 4 pi epsilon naught Q2 by R2 square. And Q3 is 1 by 4 pi epsilon naught Q3 by R3 square. Okay, fine. So, in short, I can say that electric field at origin, it is 1 by 4 pi epsilon naught times Q1 by R1 square plus Q2 by R2 square plus Q3 by R3 square. Right? Right. Is it
Fine,
okay?
sir.
Suppose
Yes, sir.
here I am having three charges, Q1, Q2, Q3. Okay.
Good. Good. Okay.
Suppose let us consider Q1 equal to positive, some
Second.
positive value. Q2 and Q3 are negative. Then instead of Q2, I'll keep minus Q2. Okay. And Q3 also, instead of Q3, I'll keep minus Q3. Okay.
Okay.
That means here we need to consider sign also. Okay, what I mean is. Now, here we are having a note. Okay. Or you can say remark. If there are small n number of charges, small n number of charges, having charge Q1, Q2, Q3, and so on to Qn, which are separated by distance by distances R1, R2, R3, and so on Rn with respect to origin. With respect to origin. Then electric field at origin is, that is E naught equal to. Previously, we are having three charges. Right.
Right.
Here I'm having the
Two.
here I'm having the n number of charges. So can I say that E naught due to Q1, E naught due to Q2, like that up to Qn,
E Q&A.
right? So electric field at origin, can I say that 1 by 4 pi epsilon naught into Q1 by R1 square plus Q2 by R2 square plus Q3 by R3 square and so on to Qn by Rn square. Right?
Fine.
Right?
Yes.
The same note, second point. This is most important.
Okay.
Even in the numerical also will get. If there are
No.
infinity number of charges, infinity number of charges having charge equal to Q, or you can take any value. Here I am taking Q, which are separated by distances R, 2R, okay, and then 4R, okay, and then 8R, and so on to infinity, okay, and so on. Then electric field at origin, that is E naught, that is nothing but E naught due to Q1, Q2, Q2, and so on to E naught due to infinity charge. Okay. Then, so E naught equal to 1 by 4 pi epsilon naught. All are having same charge Q. So Q by R square plus Q by 2R whole square, that is 4R square plus Q by 4r whole square. That is 16r square. Okay, now. And so on to infinity. Take q by r square common. 1 by 4 pi epsilon naught q by r square. So take common. 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 and so on to infinity. Right.
Right.
See here, this is the up to infinity means geometric progression.
Yeah.
S infinity means a plus ar plus ar square and so on to infinity. S infinity formula it is a by 1 minus r. A means first term, right? R means second term by first term, or next term by previous term. So it is A means 1. R means 1 by 4 by 1. Right? R equal to 1 by 4 by 1. That is nothing but 4 by 3. Fine.
Fine.
So instead of this one, I'll substitute as 4 by 3. That is electric field at origin it is 1 by 4 pi epsilon naught q by r square into 4 by 3. Don't cancel this 1 by 4 pi epsilon naught because directly I can write 9 into 10 power 9. Okay. Fine.
Fine, sir.
Yeah. Okay. Up to here it is electric field due to the multiple charges. Now, electric field due to continuous distribution and discrete distribution. Electric field, discrete distribution. Or first we'll discuss about continuous distribution. Okay, fine. Suppose I'm having a conductor, whatever be the shape, either it may be square or rectangle, okay, or circle, anything. If at any region of the conductor, the distribution of charge is same, then we can say it is continuous. Okay. It is called continuous. Suppose even in your school also, we can see, okay, either in term 1 or term 2 exams. Before the exams, okay, teacher will give the preparatory notes or some model questions, right?
Yes, sir.
So that is teacher is giving that important questions or preparatory notes to all the students. to all the students in the class. Teacher is giving the notes now. That kind of
Yes.
distribution can be called continuous distribution. Okay. Whatever the notes is there, it is equally shared to all the students. Suppose if there is an unequal sharing, then we can say it is discontinuous or discrete distribution to a particular section of students. They will give some extra notes, right?
Right.
Oh, fine. In this continuous distribution, okay, here we are having the three types of objects. First one, it is one-dimensional distribution. One-dimensional distribution. In this one-dimensional distribution, let us consider examples like as string, wire, pin rod. Okay. In all these objects, what happens it is, suppose I am considering a thin rod. Thin rod means it is having a length. The width of the thin rod, it is very small. This one, it is very small, negligibly small. Okay. Fine. Now, suppose whenever it is charged, such that positive charge lies on the outer surface, and negative charge lies inside the surface. Okay. Na?
Okay.
One end is A and another end is B. Let us consider center as O. That means each charge will distribute its effect to the next charged particle along its length. Right? Along its length, charge will be distributed. So that's why it can be called one-dimensional distribution. Okay. So at every point, we'll have the distribution is same. At every point, distribution is same. So we are having linear density, which we can indicate with lambda or sigma. That is given as total charge by total length. Okay. Na?
Okay.
Suppose total charge is Q. So Q by L. If I consider a small part, suppose if I consider this part, so in this part, charge is dq, length it is dx,
Yes.
that is dq by dx. Because at every point, inner density is same.
Yes.
Inner density same.
Yes.
Okay. Similarly, we are having two-dimensional distribution. Two-dimensional distribution. Previously, we are having the the distribution of charge along only in one dimension. So that's why we can call it an one-dimensional distribution, or it is one-dimensional distribution. In this one-dimensional distribution, we are having the linear density. Okay. For two-dimensional distribution means we have like ring, disc, square, triangle, etc. In all these, the distribution of charge will be along in two dimensions. Okay. Suppose let us consider a ring. Let us consider ring. It is charged to Q. That means positive charge lies on its outer surface. Okay. And negative charge lies inside the surface. Okay. Na? With respect to the center, I will construct Cartesian coordinate system. It is the x-axis and it is y-axis. So every charged particle will distribute its charge along x-axis and y-axis. Right?
Yeah.
Every charged particle will distribute along x-axis and y-axis. So here we are having the surface density. Okay. Fine. Or you can say surface charge density. That is charge per unit area. Okay. Total charge by area. Suppose the total charge is Q. Okay. For ring or disk means I can write pi r square. Charge thin rod at axial point. At axial point. Okay. Fine. Now, let us consider a charged thin rod. I'm having an thin rod AB having a length as 2L. We can also consider L also. For mathematical simplification here, I consider 2L. Okay. O is the center of the thin rod. Let us consider this thin rod is charged. That means positive charge lies on its outer surface. Positive charge lies on its outer surface and negative charge will be accumulated inside the thin rod. Let us consider this thin rod is having a charge as Q. Okay. Fine. Such that O is the center. So can I say that AO equal to OB equal to L? Okay. Fine. Now axial point. Axial point. Axial point means It is a point which lies along the line joining the center of the conductor. Line joining the center of the conductor. Okay, na? Man,
Yes, sir.
better, fine, na?
Fine, sir.
So, along the line joining the center of conductor means here I am touching. From the center of conductor at a distance x. At a distance x. Okay. Now, what I need to find? Find electric field at P. Electric field at P due to charged thin rod. Right? Due to charged thin rod. Here I need to find. So, as we discussed in our previous session, wherever I want to find electric field, at that point, I'll keep a test charge.
Touch, yes.
Always this test charge will be positive.
Positive.
So, there will be electric field due to B, due to the point B, and due to A. Okay. Since here distance is less, electric field is proportional to 1 by r square. As r is small, electric field is more.
More.
So, electric field due to B will be more. As distance is due to A, it is more now. As
More
distance is more means
distance.
electric field will be less.
Yes.
So, electric field at point P means, can I say that it is EP equal. EB, it is acting parallel to positive x-axis. Right? And EA is acting parallel to negative x-axis.
Negative parallel. Yeah.
So, in vector form, I can write EB I cap plus EA times minus I cap. So, EP bar equal to EB minus EA times I cap. Can I say? Okay.
Okay, sir.
Fine.
Okay.
So, EP bar equal to EB minus EA I cap. So magnitude of electric field at point P means I can say EB minus EA. Right? Fine. So
Yes.
EP means 1 by 4 pi epsilon naught. Total charge is Q by BP square minus 1 by 4 pi epsilon naught Q by AP square. Okay. Now I want to find BP distance. OP can I write as OB plus BP? Can I write?
Yes, sir.
OP means nothing but X only. No?
Yeah.
OP
Yes.
is nothing but L.
Right.
Right? If we consider length of the rod as L, here it is L by 2. Right?
And
If I consider length of the thin rod as L, then OB will be L by 2 now.
Yes, yes.
In order not to get that fractional values, I consider 2L.
2L.
Okay, now. Why I
Yes,
consider
sir.
length of the rod as 2L means not to get that
Mm.
fractional values.
That's okay.
So BP I can write as X minus L. Similarly, AP means I can write as AO plus OP. Right? AO plus OP, nothing but AP only. AO, that is L, OP is X.
PL.
Q by 4 pi epsilon naught. BP means X minus L minus 1 by X plus L whole square. Take LCM. X plus L whole square minus X minus L whole square by X plus L into X minus L whole square. Can I write?
Yes.
Numerator, it is in the form of A plus B whole square minus A minus B whole square. That is 4AB na. Right? A plus B whole square minus of A minus B whole square. Nothing but 4AB. Denominator, A plus B into A minus B, that is nothing but A square minus B square. So, electric field at point P is 1 by 4 pi epsilon naught Q into 4XL by X square minus L square whole square. Fine. Is it okay?
Okay, sir.
Okay. Na? Similarly,
Yes.
now we'll find for ring. Now we'll find for ring. Electric field due to uniformly charged ring. Uniformly charged ring at axial point. At axial point. Okay. Fine. Let us consider we are having an uniformly charged ring. Okay. Having the center as O. Whenever we say uniformly charged ring, that means that on the outer surface, it is accumulated with positive charge. Always, any conductor, whatever be the shape, outer surface will be accumulated with positive charge. Okay. And inner surface will be accumulated with the negative charge. Fine. Such that the total charge as Q. Total charge as Q. Now, let us consider capital R is the radius of the ring. Now I need to find electric field at axial point. Same as like before, axial point means point which lies along the line joining the center. Okay. So let us consider an axial point P, which is at a distance x. Is at a distance x from the center of the ring. Okay. Fine.
Yes.
Now I need to find electric field at P due to charged ring. Okay, na? Due to charged ring, I need to find here. So wherever I want to find electric field, at that place, we'll place an test charge.
Yes.
Okay.
Yes.
Okay, fine. Now let us consider an infinite small element. Yes, you can see this one. Having a charge as dq, due to this infinite small element, there will be an small electric field will act at point P. Right? Such that this small electric field makes an angle theta with respect to the axial direction. See? Okay. Fine.
Yes.
I need to find electric field along OP direction. Along OP direction, I need to find electric field. Suppose this is A. In the triangle AOP, angle A, angle APO equal to theta. Can I say? Okay. Angle APO equal to theta. So along OP direction means that is with respect to the theta, OP is adjacent side. So I'm considering cos theta. Adjacent side by hypotenuse. So that is nothing but OP by DE. So OP will be DE cos theta. Right? That is horizontal component of electric field. Fine. Is it okay?
Yes.
See the triangle AOP, AO equal to R, OP equal to X. So AP, can I say under root R square plus X square?
Right.
So DEX equal to DE into cos theta means X by under root R square plus X square. Right? It's fine. Now DE means infinite small electric field due to this infinite small element. So dx equal to, since it is a point charge, 1 by 4 pi epsilon naught dq by separation distance, that is nothing but AP. AP square into x pi square root of r square plus x square. I will write it as r square plus x square whole power half. Right? Right.
Yes.
AP equal to under root r square plus x square. So AP
Yes.
square means I can write r square plus x square whole square. That is dx equal to 1 by 4 pi epsilon naught dq into x by r square plus x square. It is AP square and x by r square plus x square whole power half. It is the cos theta. See, right? So here bases are same. Add the powers. So it will be 1 by 4 pi epsilon naught dq into x by r square plus x square whole power 3 by 2. Okay. Now, in order to find total electric field, here I have taken only the infinite small element. Now, I want to find electric field due to entire ring. To find entire ring, we'll integrate it between values 0 to EP. Total charge. With respect to charge, we are integrating. Right? Fine. So, with respect to Q, I'm integrating it. Remaining all the terms are constant only. Na? Bring it outside. 1 by 4 pi epsilon naught into x by r square plus x square whole power 3 by 2 integral dq. In generally, integral dx, can I write as x?
Yes.
Similarly, integral dx, I can write ex between value 0 to here also 0 to. Instead of ex, substitute final value minus initial value. That is EP minus 0 equal to 1 by 4 pi epsilon naught x by r square plus x square whole power 3 by 2 to small between value 0 to 10. So, electric field at point B will be 1 by 4 pi epsilon naught capital Q into x by r square plus x square whole power 3. That is the electric field due to the charged ring, charged ring at axial point. Right? This page okay na?
Yes, sir. Okay.
This page okay. This page.
Okay, sir. Yes, sir.
Now, based on this thin ring only, I want to determine at what value of x electric field at point P is maximum. Okay. At what value of X, electric field at axial point is maximum. Okay. We know that electric field due to a charged ring is 1 by 4 pi epsilon naught qx by r square plus x square whole power 3 by 2. Right? Now, exit is the distance from center of the ring to the outside point now. Okay.
Yes.
As x increases, what will happen to electric field? As x increases, what will happen to electric field?
X will increase, the electric field will decrease with the distance.
Right? As distance increases, electric field decreases. DC.
Decreases.
Okay. So that means
Yes.
there is a variation between x and electric field. So I'll differentiate it. dE2 by dx must be equal to 0. Right? dE2 by dx equal to 0. Differentiate it. That is d by dx of 1 by 4 pi epsilon naught 2x by r square plus x square whole power 3 by 2 equal to 0. Q by 4 pi epsilon naught is a constant. Bring it outside. d by dx of x by r square plus x square whole power 3 by 2 equal to 0. Right?
Yes.
Bring this q by 4 pi epsilon naught, it is a constant, to the right side. So d by dx of x by r square plus x square whole power 3 by 2 is equal to 0. Since numerator and denominator both are functions of x only, and it is in the form of u by v, d by dx of u by v. That is v into du by dx minus u times dv by dx upon v square. Right?
Right, sir.
So it will be v square means r square plus x square whole cube. Okay. Now v means r square plus x square whole power 3 by 2 d by dx of u, that is x minus x into d by dx of r square plus x square whole power 3 by 2 is equal to 0. Cross multiply. So it is r square plus x square whole power 3 by 2 d by dx of x. What is the value? 1 now.
Yes, sorry. Yes.
Minus, listen here carefully,
Okay.
d by dx of r square plus x square whole power 3 by 2 now. I will consider this r square plus x square whole power r square plus x square as x.
Plus square x.
That is d by dx of x power 3 by 2 means 3 by 2 into x power half. Right?
Right. Yes.
Okay.
Keyboard yes.
So
Half, yeah.
similarly, 3 by 2 into instead of x, we are having r square plus x square. Right? Whole power half. Instead of x, we are having r square plus x square. So again, we need to differentiate. D by dx of r square plus x square is equal to 0. So r square plus x square whole power 3 by 2 minus 3x by 2 into r square plus x square whole power half. Capital R means radius, which is a constant.
Yes. Constant.
Okay. So d by dx of constant means 0.
0.
D by dx of x square. What is the value?
1/2.
Here n equal to 2 now. N into x power n minus 1 now.
-1.
So
Yes. Sorry,
2
sir.
into x power 2 minus 1. That is 2x.
2 -1. 2x. Yes. Sorry.
Okay.
Yes. Yes.
R square plus x square whole power 3 by 2 minus 3x square r square plus x square whole power half is equal to 0.
Uh,
Okay. So in both the terms, can I take r square plus x square whole power half common?
common. Yeah.
Otherwise, I think you are PCB or PCMB student.
PCB.
PCB, yeah. Okay, do one thing. This 3x square into r square plus x square whole power half. Bring this side. R square plus x square whole power 3 by 2, I can write as r square plus x square into r square plus x square whole power half. Bases are same. You can add powers. You will get same. Right? Fine. So r square plus x square whole power half will get cancelled on both sides.
Let's see. So, it will- so, so,
Okay.
okay. So,
So r square plus x square equal to 3x square. So r square equal to 2x square. R equal to root 2x. That is x equal to r by root 2. Right?
like,
So that means at x equal to r by root 2, electric field is maximum? Okay. Electric field
Okay.
is maximum.
Maximum.
So maximum electric field we are finding. That is 1 by 4 pi epsilon naught. Formula it is capital Q into X by R square plus X square whole power 3 by 2. Instead of X, I am substituting R by root. That is Q by 4 pi epsilon naught R by root 2 by R square plus R square by 2 whole power 3 by 2. That is Q by 4 pi epsilon naught R by root 2. I'll write as 2 power half. Here it is 3R square by 2 whole power 3 by 2. Right. So it is Q by 4 pi epsilon naught into R by 2 power half. Okay. 3 by 2 whole power 3 by 2. I'm writing as 3 by 2 into 3 by 2 whole power 1 by 2. Right. R square whole power 3 by 2 means R cube. Right.
Ah.
This 2 power half, this 2 power half cancel. So Q by 4 pi epsilon naught into Q by 3 root 3 R square or E maximum equal to 1 times 2 times 1 by 6 pi epsilon naught into Q by root 3 R square. Right.
Right.
That is the maximum electric field.
Field. Okay, sir.
Right. And that is what up to here it is electric field. Okay.
Electric field.
Uh,
Okay.
Once you go through the NCERT textbook, okay, your NCERT textbook, okay, and
Yeah.
if any topic is missed, let me know. I think it is
Okay, sir.
this electric field into point charge and then multiple charge and then this. Okay. In your
Yes.
textbook, they didn't give this electric field due to charge ring, but in
Yes.
CBSE exams, they asked questions.
Okay.
Okay, either in all over India paper or in Delhi paper.